Example 4.2.1. The setup for this one says you have an investment opportunity. If you invest some amount today, you will receive $2,000 in 1 year, $3,000 in 2 years, $3,500 in 3 years. You believe that an 8% rate of return will compensate you for the risk of this investment. How much should you pay today to receive the expected future cash flows and earn an 8% rate of return? Okay, so in this chapter, we've introduced a three-step process for solving any time value of money problem, where a time value of money problem is one that just involves cash flows over time that we need to evaluate. So that three-step process we can see in the cash flow type and tools cheat sheet that's published in the course. That three-step process is up front. We're going to start by drawing the timeline and labeling all known information, all the information that's given to us in the problem. Then we're going to use that timeline to identify the type of cash flow we're looking at, and it's going to be some flavor of one of these three. It's going to be either a lump sum, an annuity, or a perpetuity. And then, once we've identified the cash flow type, we can apply the appropriate time value of money tool to solve for the missing variable, whichever one it is we're trying to solve for. Now, this cheat sheet has the three types of cash flows broken down. It starts with lump sums, and then we look at perpetuities, and then it looks at annuities. And for each cash flow type, we see a timeline example of what that cash flow might look like on a timeline. And then we have a list of tools available to evaluate that particular type of cash flow for each one of them. And for the formulas, we'll see the formulas that you can apply to those particular cash flows if we're going that route. And if we look at the end of this document, we'll see all of that summarized in table form. We'll have the different types of cash flows along the left-hand side. And then we have the three tools available to us to solve these problems. The formulas will, of course, work for all types of cash flows. For the financial calculator, there are two tools within it. There's the time value money keys and the cash flow worksheet that it can apply to various types of cash flows. And we'll look at both of those or all three of those solutions if they're available for each problem. I also list the spreadsheet solution that is available for all of the types of cash flows. We won't focus on the spreadsheet solutions in these videos, though, because typically that's not available to students on an exam, whereas the formula solutions and the financial calculator tool are available to students on the exam. So most of these videos are going to focus on just those solutions, whichever ones happen to be available for a given problem. Okay, so let's apply this three-step process. We're going to start by drawing the timeline for this particular problem. So at time period 0 in this problem, we have no cash flow. The first cash flow that we see is a receipt of $2,000 in 1 year. So there's nothing happening at time period 0. At time period 1, we will have a cash inflow of $2,000. Time period 2, we'll have a cash inflow of $3,000. And then at the end of year 3, or 3 years from today, we'll have another cash inflow of $3,500. Okay, there's one more piece of information given to us in the problem, and that is the rate of return of 8%. So our R equals 8% in this problem. Okay? And the question is, how much should we pay today to receive these expected future cash flows and earn an 8% rate of return? Well, another way of looking at that, or a way to come up with that value, is to take each of these future cash flows and discount them back to time period $0 at an 8% discount rate. Right? And the present value we come up with when we do that, whatever that amount is, if we were to invest that amount today and then receive these future cash flows that were promised in this investment, we would earn an 8% rate of return because we discounted each one of these cash flows back to time period $0 at 8% in order to come up with that amount. Okay, so this is our timeline. This is step 1. We've drawn the timeline and labeled all information. The next step is to identify the type of cash flow that we're looking at. So I've got three cash inflows in this example. I've got 2,000, 3,000, and then 3,500. These don't appear to be related by a fixed growth rate at all. It's not like the second cash flow is X percent higher than the first one, and then the third cash flow is that same X percent higher than the second one. They seem to be three random cash inflows that just aren't related by a set rate. So let's look over at our cheat sheet and see if we can find a timeline that looks like this type of cash flow. And I'm just going to start at the beginning with lump sum. All right, and we see two timeline examples for lump sums, and that's because they will often take two forms. The first is just a single lump sum cash flow, and an example of that would be a cash outflow, some cash outflow today, and then some cash inflow at the end of my timeline or some point on the timeline. And those are the only cash flows involved, just the one. Well, that's not what we're dealing with here. We have more than one cash flow, so it doesn't quite look like that one. If I look at the next timeline example, though, under lump sums, I have something that looks pretty familiar here. In fact, it looks very familiar. We've got a present value unknown at time period 0, and then we have three cash inflows that don't appear to be related by any sort of set growth rate. They're just three different cash inflows on this timeline. And this is exactly what our timeline looks like for this particular problem. Different amounts, of course, but the same general setup. So this looks like a mixed stream of lump sums. It's a mixed stream of lump sum cash flows. I'll just say CF for short. All right, so once I've identified it as a mixed stream of lump sum cash flows, if I look back at my cheat sheet, I can see the tools that are available to evaluate this type of cash flow. I can use the present value, future value of a lump sum formula, which we see in two different forms now. In Chapter 3, we saw it as just a single cash flow, where present value is equal to future value, divided by 1 plus r to the n. In Chapter 4, when we have a string of lump sum cash flows like this, we can just take this same formula and repeat it over and over again, where the present value is equal to future value 1 divided by 1 plus r to the 1. So we discount that first cash flow back one period. We add to that the second cash flow, future value 2, that's discounted back 2 periods, and then so on for however many cash flows we happen to have. So these two equations, equation 3.2 and equation 4.01, are identical. It's just that in 4.01 we have multiple cash flows that we're summing together once we've converted each one to present value. So equation 4.01 is really just using equation 3.2 over and over again and summing those present values once you've done it. Okay, so we'll start with the formula solution. We can also see that the financial calculator is available to us, and we'll look at that solution as well. Let's start with the formula solution, though, and we're going to use equation 4.01 for this. All right, we'll start with the formula, where we have three cash flows in this case. So our present value, which is what we're looking for, at time period 0 is going to be equal to the future value, the first future value, cash flow at end of year 1, times 1 plus our discount rate, raised to the 1, because we're going to take this 2,000 and bring it back one period, plus our second future value, this $3,000 cash inflow. That's going to have to come back 2 periods because it happens at the end of year 2. Let's see if we can get all this on here so we can actually see the timeline. There we go. And then we're going to need to add to that the third future value, this 3,500 that happens at the end of year 3. And that is going to need to be discounted back 3 periods. So we'll have our superscript 3 there. Okay, let's plug in these cash flows into the actual formula and add them up. So our present value at time period 0, we start with this $2,000. And our discount rate is 8%. That we plug in for our R there. 1 plus 8%, or 8% expressed as a decimal, is 0.08. So 1 plus 0.08. Discounted back one period. Our second cash flow at the end of year 3 is a cash inflow of 3,000. And divided by 1.08, this one's raised to the 2 because it needs to be discounted back 2 periods. And then our third cash inflow of 3,500 Again, divided by 1.08. This one's raised to the 3 because it needs to be discounted back 3 periods. All right, so let's actually calculate each one of those. 2,000 divided by 1.08 raised to the 1 is 1,851.85-ish. And I'm actually going to store this value, so I'm going to write a note to myself, STO1, underneath that. And I'm going to press STO for store, and then the number 1 key to store this. Remember in the calculator setup video, although I have this set to show me 4 decimal places, it's actually working it out internally to 12 or 13 decimal places. So when I say STO1, it's storing the full 13 decimal version on the number 1 key, and I can pull that back up later when it's time to add these guys together. And I can reduce rounding errors that way. All right, the next one is 3,000 divided by 1.08 raised to the 2. So I'm going to press the x squared key and equals 2,572.02 round to the nearest penny. And I'm going to store that on the 2 key. So STO2 to store it on the 2 key. And then plus, finally the last one, 3,500 divided by 1.08. I need to raise that to the 3. So on the BA2 Plus, the way I'm going to do that is while 1.08 is on the display, I will press the Y to the X key, which is right above the 9. And that tells the calculator that what's on the display right now, I want you to raise it to what I'm going to type in next. For this problem, that's 3, so I'll press the 3 key, and then equals, and it'll raise that 1.08 to the 3 and then do the division for me. 2,778.41 roughly. And we'll store that on the 3 key just in case I make a mistake here in a second. I have to start over. All right, so while this one's on the display, remember it's worked out to 12 or 13 decimal places. I'm going to hit plus, recall 2, and that'll add it to the number that we stored on the 2 key. And then plus, recall 1, which will add to that sum what was stored on the 1 key. And I can press equals and find that our present value as of time period 0, once I discount all 3 of these cash flows back to time period 0, is $7,202.28. So if I were to pay for this investment $7,202.28 today, I would invest that today, I'd pay it out, and then over the next 3 years I would receive cash inflows of $2,000, $3,000, and $3,500. Once I receive that last cash inflow of $3,500, I will have earned an 8% rate of return. And we know that because we calculated that present value using an 8% discount rate. So we found the present value of those 3 cash flows discounted at 8% back to today's dollars. So we know that those are equivalent. This present value is equivalent to these 3 future values discounted back at 8%. Okay, that's the formula solution. For the time value money keys on the calculator, we have the time value money keys across the top that we can also use because this is a lump sum. We also have the cash flow worksheet. I'm actually going to skip over the time value money keys solution in favor of the cash flow worksheet because if you see in the example solution, if you use the time value money keys, we have to do 1 cash flow at a time, just like we did with the formulas. So I'd find the present value of the $2,000, store it, the present value of the $3,000, store it, present value of the $3,500, store it. Well, if I'm going to use a shortcut in the calculator, I might as well use the best shortcut available, and in this case, that is the cash flow worksheet. All right, and the way we get into the cash flow worksheet on this calculator is by pressing the CF button, which is on the 2nd row right next to the 2nd key. So I'll press CF, and this guy is a memory function, just like the time value money keys that we looked at in Chapter 3. So whatever problem I worked in there last is still stored in here. So I'm going to start out by clearing this thing out. And the way we clear out the cash flow worksheet is a little bit different. We start by hitting the 2nd key, and then we press clear work on the bottom left, which is attached to the clear key. So second and clear work will zero out all the entries inside the cash flow worksheet. All right, now we can enter the cash flows just like they appear on the timeline. CF0 is what cash flow happens at time period 0. Now in this problem, we're actually going to solve for present value. We want to solve for the cash flow at time period 0. So I'm going to skip over this guy. I'm just going to leave it as 0 as it is by default. And I'm going to press the down arrow key to go to the next entry. When I hit the down arrow key, I see CO1. That stands for cash flow 1. That is what happens at the first tick mark on your timeline. And in this particular example, at the first tick mark on our timeline, I have a cash inflow of $2,000. So I'm going to enter 2,000. And once that's on the display, I have to press the enter key to store it on the CO1 value. And once I hit the enter key, I'll see an equal sign come up, however many decimal places I have my calculator set to display, and a sideways triangle to tell me that that value is stored. So on CO1, we entered a positive $2,000 because it was a cash inflow. Then we hit the enter key to store it. And once that's stored, we're going to hit the down arrow key to go to the next entry. When I go to the next entry and I hit that down arrow key, I get FO1. FO1 stands for the frequency of cash flow 1. That is, how many times in a row do you receive the cash flow, or do you see the cash flow that you put on the CO1 key? For us, that was $2,000. And if we look back at our timeline, if we look at the next cash flow, it's different. It's $3,000. And so this $2,000 cash flow only happens once in a row. We only see it once. So we want to leave FO1 set to 1, which it is by default. Okay, so we can leave that guy alone. You see the sideways triangle in our decimal, so it's already a stored value. We don't have to press enter. We can just hit the down arrow key to go to the next entry. Okay, when we hit the down arrow key, we get CO2 as the next entry, which stands for cash flow 2, or what is the next different cash flow on your timeline. For us, that was a cash inflow of $3,000, so we're going to enter 3,000 and then press enter to store it. All right, so we typed in 3,000 and then we pressed enter to store it. And then, you probably guessed it by now, we'll hit the down arrow key to go to the next entry. And now we'll see a pattern emerge here. I'm going to get FO2, which is the frequency of cash flow 2. How many times in a row do we see that $3,000 cash inflow that we just entered? And it's only going to be once again, because the next cash flow that we see is a cash inflow of $3,500, which is different than what we just entered. So we're going to leave that guy set to 1 and just press the down arrow key to go to the next entry, which comes up as CO3, or cash flow 3. In our case, the third cash flow is a cash inflow of $3,500. So we'll type that in and then press enter to store it. All right, and then we'll hit the down arrow key to go to the next entry, which comes up as FO3. That is, how many times in a row do we see that cash flow of $3,500? Well, again, it's just once, which it is by default. And now we've got our entire timeline entered into the cash flow worksheet. Now, this worksheet is a memory function. So one of the things I like to do is to make sure that it actually cleared out and the cash flows that I've entered are the only ones in there. And the way I do that is by hitting the down arrow key a few times just to see if there's anything else in the worksheet. When I hit the down arrow key, cash flow 4 is set to 0, and notice that nothing is stored. There's no equal sign, there's no sideways triangle, which tells me nothing is stored there, which is a good sign. That's what I'm hoping for. If I hit it one more time, FO4, notice it's no longer 1 by default. There's no sideways triangle, there's no equal sign, so there's nothing stored on the FO4 key, which is great. That's what I'm looking for. If I hit the down arrow key one more time, if there's really nothing else in there, it should take me back to cash flow 0, and it does. So now I know for sure that there's nothing else in the calculator. Okay, I've got these future cash flows entered. I want to find the present value of them. So the way I do that from the cash flow worksheet is by pressing the NPV key, which stands for net present value, that we'll look at in a later chapter. Net present value just means it takes the present value of the future cash flows and subtracts from it the present value of any cash outflows. In this case, we don't have any cash outflows. We're trying to figure that out. So net present value for this set of entries is just going to be plain old present value that we've been working with for Chapter 3 and Chapter 4. So when I press the NPV key, though, something interesting is going to happen. I press the NPV key and it asks for I, or an interest rate. Right, so I'm asking it to calculate present value, but I have not given it a discount rate yet, and that's now what it's looking for. So I need to enter that. I'm going to say our discount rate in this problem is 8%, and just like the I over Y key on the time value money keys, it is expecting a percentage. So if I want to discount these cash flows at 8%, I actually type in 8, not 0.08 as a decimal, but 8 as 8%. So I'll type in 8 and press enter to store it. And then I can hit either the up or down arrow key, just as a matter of habit. I hit the down arrow key to go back to net present value, and now it says NPV equals. We have nothing there because we haven't calculated it yet, but we do see the compute prompt in the top left, and the calculator is telling us that it now has enough information to calculate the present value or the net present value of these cash flows. Would we like to do it? And yes, of course we would. That's why we entered them. So to force that computation, we hit the compute key or the CPT key on the top left. It'll run that same set of equations that we did manually just a moment ago, and it will come back with net present value equals that same value of $7,202.28 that we found using the formulas by hand. Now, we spent a lot of time walking through that cash flow worksheet just because it's the first time that we've seen it, but this process is a lot faster and a lot less error prone. There's a lot less opportunity to hit something wrong or add the wrong values together than doing the formulas by hand. So while there's a great deal of value in working with the formulas, especially in Chapter 3 when the cash flows are simpler, just to get a feel for what time value of money mechanics look like, how they're operating. Once we start getting into multiple cash flows in Chapter 4, the calculator becomes a much faster solution that can reduce error significantly as long as you know what the answer should look like, which is what doing them by hand in Chapter 3 helped us develop an intuition for.